Hello, this is Joe Bakos, and I'm here. I want to share with you a little bit about GaaWF. That's what I've decided to call it, gravity as a wave function, and I pronounce that GaaWF. So what I'd like to do is share what I've been finding out as far as doing simulations. Um, Here I've put in red the Newtonian force law, and my idea is that if gravity varies as a wave function, I thought in order to show stability, I would just do kind of a random wave function that you could see here is roughly following the Newtonian, but I want a cyclic function that has both positive and negative values that follows along the Newtonian graph. And I want to do that just because I'm trying to show that if you have some kind of cyclic wave function with positive and negative values and you leave it run for a long time, so the equivalent of like millions or billions of years for a solar system, that this will over time allow for orbits that are circular and stable. And this is the function that I've actually entered in. And as I said up above, you can see something similar to Newton's law. And that is what I'm going to be using in the simulation just to demonstrate what I'm saying. So this is the simulator. Now before I say anything about the simulator, I want to first give them credit. It's more or less of a toy, but it's excellent because you can very quickly get a kind of qualitative feel for the effect of force laws. It uses simulated units like simulated distance, simulated mass, simulated time. And so it isn't strictly speaking going to prove anything. You'd need a more high-tech simulator for that. But it can give you a feel, just a general feel for if you vary the force law, what it might do. So I'm using this Test Tube Games, the gravity simulator, and I'd like to give them credit for that. So let's go ahead and do this. So I put these planets here. I put a couple of them. Planets 1 and 2 are very large planets compared to the others. And the only real thing I'm doing is I want to make all the planets go counterclockwise. I'm varying their speeds and positions and so forth. And then just kind of run it kind of at random and just see what happens. I also made the speed such that they don't go just rocketing out of the solar system. So I want them to go into some kind of orbit, but they're not going to start with circular orbits. Also, I'd like to share my settings. So these are the current settings I'm using, and rather than have you copy this all down, manually, anybody who requests it, I can send them these settings. So if you send me a request, I can give you these settings so that you can copy and paste them. So now I am just going to start it out. So here is where I put the force law, and it is the law that I shared earlier that was in Desmos. And then the time setting, I'm going to start off kind of slow. Maybe I'm going to set it at 10, and then we'll speed it up faster later so that we can see what happens over a long period of time. So here I go. I am going to go ahead and play this. And I have tracking turned on just so that you can see how all of the orbits kind of start off sort of wild. And here I'll turn tracking off. I'm going to turn up the speed here to 100. This is the time speed, so it's going like super, super fast. And then you can see periodically, I'm going to turn the tracking on. So right now we're at like 15,000 years, sim years, and this is what the orbits look like to start with. Okay, so now I'm going to pause the recording and just periodically I'll turn it on and show you the orbits. So now I'm up getting around 100,000 years. Let me turn on tracking here. And you can see things are starting to become a little more regular. I'm going to turn the time down a little bit and turn tracking off so you can kind of see there are the planets circulating. And some of them are going, let's put it up to speed 10. And you can see some of the orbits are kind of starting to circularize. And And then we have other orbits, like this planet 11 is doing something kind of elliptical. I mean, it's not strictly speaking elliptical because it's more going to end up kind of like a flower shape, sort of like the old-time spirograph. Okay, so then let me proceed. So I'm going to look at it now around 200,000 years. Let me put on tracking here. Well, first we'll look at its slow speed. So there it is, slow speed. Put on tracking. This is what it's looking like around 200,000 years. So a lot of the planets have been kicked out, but several are still here. Let's turn it up to high speed. And we can see that planet 11 is and planet 10, they're coming in on very kind of large elliptical orbits. All right, now we're around 350,000. Let me turn on tracking so we can see what the orbits look like. And you can see they're getting a lot more circular as time goes on. Everything is settling into a very circular form. And I'll turn off the tracking and let me turn down the speed so you can see it a little better. And so there the planets are in their circular orbits, and let's continue. So I'm up past 400,000 years now. I'm going to turn the speed down so you can see it. And there's one thing I'd like to take note of as I put on tracking here, and that is some of this wavy type orbit that looks sort of like braids. Now I bring that up because recently I found this photo of some orbits of Saturn, some of the rings of Saturn. They also exhibit this sort of wave-like back and forth motion in Saturn's rings. And so I think that this is evidence of the wave nature of the variance of the force of gravity. So let me proceed a little further and see how much more this circularizes. So now I'm up at around 700,000 years. Let's see what it takes, what it looks like. You can see it's becoming much more circular. And the planets that were in very large elliptical orbits seem to have moved. The period is very long now for those large orbits. And they seem to have moved outside the inner system. So let me just show you what it looks like at slow speed. So we can see all the planets in the inner system have settled into very circular orbits. And we'll check one more time out above a million sim years. Okay, so now let's slow it down. I'm up right near a million years, a million sim years, and let's see what it looks like. So here are the planets orbiting. I'll turn on tracking here. Let me put it to speed 10, a little bit faster than that. And turn on tracking, and here are the planets. Now I started off with 12 planets, and so we could see that almost everything that remains close into the system just becomes very circular. Let me turn off tracking and see how many planets we have. I started with 12, so it looks like what? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like 10 out of the 12 have stayed in close to the system and stabilized. So next I'm going to load up the same group of planets, but then change it to compare it to the Newtonian law. So I'll do that next. So now I'd like to try Newtonian. So notice I changed this to the Newtonian law, 1 over r squared. The only other changes I made, this planet 1, I reduced its speed to 1.5. And these other planets, I changed their speed to 4. And other than that, all the settings are the same. And so let us go ahead and play. And a bunch of them take off, a bunch of them stay in orbit, and I am going to change it. Well, let's track first to see what it looks like at the beginning. So also under Newtonian, you do get some of these flower shapes to begin with, although they kind of settle out of that. So now I'm going to turn off tracking, turn up the speed, and let it run for a while. Now, what I find always, no matter how I start the planets with Newtonian, what I find is after a very short while, all the small planets kind of disappear and are sort of slung out of the system by the large planets. So by the time it settles down, what I end up with is always like one or two planets in some kind of elliptical orbit. I haven't found any go too circular yet. And so I always end up with something like this, a very reduced system with one planet that managed to achieve an elliptical orbit, or maybe a couple, but most of the stuff gets lost or slung out of the system. Well, thank you very much for watching, and I think that's about it.